Hello and good day. I am Ingrid Donnelly on behalf of the IEEE, the professional home for the engineering and technology community worldwide. Welcome and happy IEEE Day. We are thrilled to have you join us for today's session, Decode the Network, Essential 5G 6G Protocols for Real-World Impact. As 5G continues to evolve, and with 6G on the horizon, engineers are at the forefront of building, deploying, and optimizing the infrastructure that powers our connected world. But with rapid innovation comes complexity. Foundational protocols like the NF framework, registration procedures, and PDU session establishment are critical to system performance. Yet, many professionals lack the hands-on experience needed to apply them effectively. Together, we'll explore how 5G, 6G protocols and procedures are shaping the future and how you can be a part of that transformation. Next slide. I am here today with Maziar, who brings deep technical expertise as a senior telecoms trainer with Raycastle, and Brad Closa, who leads strategic initiatives with IEEE Future Directions, helping to shape the roadmap for emerging technologies. Again, I'm Ingrid Donnelly, continuing education product manager. I focus on developing continuing education programs that help engineering and tech professionals stay ahead in fast-moving fields like telecom. We're excited to share our combined insights with you today. Next slide, please. Before we dive in, just a few quick housekeeping notes. If you need technical support, press the F1 key. To ask a question, open the Q&A portlet and send your questions to all panelists. And we'd love to hear from you. Feel free to use the chat and reactions to share your thoughts throughout the session. What's changing in wireless networks? Let's start with the big picture. 5G already transformed how devices communicate, enabling everything from remote surgery to smart factories. But it's not stopping there. Artificial intelligence is making networks smarter and more responsive. And 6G, it promises even greater flexibility and reliability, especially in complex environments like autonomous vehicles and smart cities. As networks evolve, the demand for skilled professionals who understand these systems is only going to grow. Next slide, please. The numbers speak for themselves. By 2028, over 7.7 billion people are expected to be using 5G. This technology is already powering smart cities, remote healthcare, and cloud gaming. Countries like the US, UK, Germany, China, and South Korea are leading the charge. And with 6G in development, targeting speeds up to 9,000 times faster than 5G, we're looking at a future of intelligent, ultra-fast connectivity. Next slide, please. What is challenging industry? At this year's Mobile World Congress, IEEE ran an interactive experiment asking industry attendees to vote on the biggest innovations as well as the challenges they face. The top challenge was skills shortage. This sparked conversations about how IEEE's training programs can help bridge the gap, something we'll explore more today. Next slide. That brings us to the heart of today's session. IEEE and Raycastle have partnered to create a powerful training experience. The 5G, 6G Essential Protocols and Procedures Training and Innovation Testbed. This training blends deep theoretical knowledge with hands-on practice using a secure cloud-based testbed that simulates real-world 5G networks. It's designed to help professionals not only just understand, but apply critical telecom protocols. To learn more, we will pass it over to Ray Castle, who will dive deeper into a portion of the training, followed by Brad, who will share details on the innovation test bed. Did we want to start with you, Brad?
Yeah, I'm happy to.
Right
We
there. Yeah. Awesome. Okay. I'll pass it over to you, Brad. And now that you can go over some highlights and key components of the innovation test bed.
Thanks, Ingrid. And hello, everybody. My name is Brad Cloza, and I'm a program director at IEEE. And I manage the IEEE 5G 6G innovation test bed. And this is a new platform from IEEE. It has only been available, for just over a year. And it is, we created it because we wanted to have a low cost opportunity for people who are interested in developing and testing 5G products, services, or innovations for 5G networks. And so what it is a cloud native end-to-end 5G network testing and development platform. It is into an integration of a lot of open source components, but there are proprietary components in there as well. And although it's cloud native, it's also a hybrid system. And so we encourage people to, have hardware that they can connect to their IEEE account if they are looking to do physical layer testing or if they need to test their hardware. Uh, and our users can also not only connect their hardware, they can also upload their software to interact with the development platform as well. And so the platform can help with interoperability and conformance testing, load testing, security testing, and more. But it's also a very good place just for sandbox innovation. If you have new ideas for products or services or network optimizations, if you want to develop APIs that can affect the network or apps that can affect the network, this is a good spot to do that. And it can significantly reduce testing and development costs. And most importantly, I think, is that it can shorten the feedback loop. The ability to do a lot of early stage testing and get bugs worked out in this cloud focused environment can really speed the time that what you're developing can become a reality and then get to market. And it's open all around the world for industry and academia, and I'll touch a little bit on how the benefits align for both of those sectors. Next slide, please. So we have multiple architectures available, and it's very flexible and it's also customizable. Each customer gets their own unique version of this architecture. And the basic is this 5G network in the cloud. This is fully virtual from end to end. And because it's fully virtual, of course, on the radio side, the RAN is emulated and the user traffic and devices are emulated. We also have an environment like that for multi-access edge computing or MEC testing. So if you're doing testing or experimentation on the edge, such as IoT, there's a special environment for that. We have implemented the ability to test and develop Open RAN. Again, this is available fully virtually, and this includes a RAN intelligent controller or RIC, and that provides support for XApp development and testing. Physical access points, we have a physical access point at IEEE. Certain users of ours can get access to that hardware and run tests through it remotely, so you can log in, set up, and run a test. But we also have this very strong bring your own hardware philosophy that most of our users tend to want to take advantage of if they want to connect hardware. And that's where we can create a connection to their lab from their IEEE testbed account in the cloud. Next slide, please. We make a lot of tools available to users in the account that they get. A lot of these are open source, but some of them are not. A big one is the Camara API project, the global Telco Alliance. And we make a bunch of those, the APIs that have been created through the Camara project available in the test bed to experiment with. But we also support developing your own APIs to include in your testing. AMCOP and Nixon are two of the uh, tools that are not open source. And we're starting to see companies like those, Arna Networks and Nixon, see value in adding their tool sets to the IEEE testbed because it gives visibility for their products and their capabilities to all of our users. Next slide, please. So the key benefits for industry, as I mentioned before, is this idea of shortening the feedback loop. You get a lot of early stage trial and error done efficiently because of the cloud-based environment. And that will ultimately accelerate your time to market, whether you're creating a new product or services, or if you're developing network optimizations. And so we think this cost effectiveness is going to help companies optimize their ROI. And this is true for product development, network services development. We can create a virtual space where partner companies can collaborate together in a secure, private, virtual, cloud-based location where they're working on projects together in the cloud. And this is also a nice a platform for upskilling your workforce, whether it's young employees who need to get up to speed on 5G or veteran employees who might be well versed in 3G and 4G, but need to understand 5G a little bit better. So being in the environment and seeing how things work is really good for an upskilling opportunity. Next slide. Now, in academia, our users are using it in two different ways. The way that we're seeing the most positive results is through research projects. We have a lot of universities that are doing PhD research projects in the test bed, and a lot of times the results they get are being published in conferences or in journal papers. And the idea here is that, a lot of times students or faculty might have an idea, a theoretical concept for some way to optimize a 5G network or create a new network slicing protocol or an algorithm that can control the radio interface. And now, rather than just write about their idea in a paper, they can take that idea into the test bed, generate some actual data sets that can hopefully validate their theory. And when they have data to back up their theory, it makes their presentation, whether it's a paper presented at a conference or submitted to a journal, that much stronger. And we have ties with IEEE Dataport. There's a special location in Dataport to publish IEEE testbed data sets. And those data sets can then be referenced in IEEE Explore papers. But the other way academia is using the test bed is just as part of the curriculum. And the simple idea here is you learn something in the classroom and then you can try it in the test bed. So it's like a lab environment where whether it's network slicing or security protocols, whatever point of the curriculum you are in the class, then you can send the students into the test bed to do some experiments that give them a bit of a hands-on understanding of how things work, and which hopefully gives them a leg up when they're ready to enter the job market. Next slide. This is a list of the features or scenarios or capabilities that we've implemented so far. We do have a development team that's continually adding more features on a full-time basis. So this list does grow over time, and we love getting feedback from our users on what we should add to our roadmap. Next slide. These are a couple of testimonials from some of our users. University of Calgary, they've developed algorithms for network slicing scenarios, and they've implemented their algorithms into the testbed environment to get results on how they would perform in a live network. And they've been working on that project for about a year and a half now. Their lead faculty person is very happy with how things are going, and we're really glad to see the progress of their project. And then Rima from Princess Samaya University, she was under the gun to finish her PhD thesis. she needed to generate a realistic 5G smart grid traffic data set to evaluate anomaly detection and self-healing mechanisms. And she found that the testbed enabled her to do that in a really efficient amount of time and got her ready to publish her, an important part of her PhD. And I love the quote from her saying, working with it felt like discovering Alibaba's secret treasure. Suddenly I had world-class 5G infrastructure at my fingertips. She did not have a lab at her university, and so this enabled her to generate data like that. Next slide. And this is a short recorded demo of the user interface of the 5G testbed, and I'm going to rely on Amy to get it played. Testbed user interface. This is the dashboard that you land on when you log in. It is a live view of your network. So the G-Node B, it says it's connected and it's green. If it was not connected, it would be red and it would say disconnected. And that's true for a lot of the other tools and use cases, whether they're enabled or not. But to get to work, you might start by checking on the configuration of your G-Node B. You can also look at the up-to-the-minute information about that G-Node B, and you can come get the logs from it at any time. In the UE section, you'll see what UEs or devices are connected to the network. These are all virtual UEs or devices assigned to this user account. And you can, for instance, here, register UE. It will go from navy to light blue. And so these are the devices that are registered to the network. And if you go in operations, it will only show those devices. You could look at the details. It will give you the info, status, timers, RLS state coverage, and the tunnel info of where the data is flowing. You can get a speed test on any individual device, establish a PDU session, or deregister it from the network, and then we'll go back down to 3. In the 5G core, you get an up-to-the-minute details about your core. It will list all of the 5G core network functions and the status and details of your 5G network core functions. In tracing, this is where you can start to record tests or experiments. You click Start Trace, you give it a name, and everything from there on out gets recorded for closer inspection later on. Once you get one of those traces, you can look at it, and it shows you this sequence diagram. This is a simple one I'd done, just deregistering a device from the network. But if you do particularly long experiments and the traces get complicated and very long to look at, that's when you might want to take your trace file and go into the tools and go to Trace Analyzer, where it will turn your basic trace sequence diagram into an interactive one so that you can click into and out of various parts of the recording that you did. But then in monitoring, we also give access to the Grafana dashboard. This will allow you to create a dashboard that's much more customized for whatever is important to you. The amount of metrics Grafana gives you access to is really pretty impressive, and you can customize it so that when you click into your Grafana dashboard, the metrics that are the most important to you are the ones that are front and center. In use cases, we have integrated the Camara API project, and so we give you access to a bunch of the APIs that have come out of the Camara project. And if you're developing new APIs, you can do that in here and then potentially include them for long-term use by other testbed users. In network slicing, we give everybody 4 slices to start with. You can add more if need be. 4 is a good starting point, and this is where you can configure and deploy the slicing scenarios that you want to work in. Then in tools, you can have direct access to a Linux terminal. There are traffic control and network simulator. These allow you to
not only measure network performance, but also inject various types of traffic manipulations, congestion, data corruptions for experimental and testing purposes. Open speed test will allow you to do speed and performance testing. Trace analyzer we covered. And then we included a denial of service attack tool where you can start a denial of service attack scenario. You choose what kind of attack, and then you can define the burst rate, duration, and wait period between attacks if you want to investigate security, cybersecurity protocols, and use the attack tool to test the performance of your security measures. Resources, we provide all the user documentation, user guides, which you can view right in the interface, or you can download them to read them offline. There are a lot of user guides for depending on what it is you need to do. And we also have videos if you prefer to watch how to do something rather than read about it. These tutorial videos of some of the more important or most used tests and experiments are in here. And this is a sneak peek because this is our development area. We are working on some AI use cases and tools that we hope to release to users in the next couple of months. And that is the quick tour. I tried to go really fast. Hopefully it wasn't too fast. But if you have any additional questions, you can reach out to the testbed team. Thanks very much.
Okay, so that's it for me. I will note that the testbed is available at an annual subscription for organizations. So an institution, a company or a university or some organization can get an account, and all their staff or faculty or students can get access to it. But I also want to note that for the Ray Castle IEEE 5G 6G protocols, essential protocols course, anyone who takes that course will get a 3-month complimentary access to the testbed as an individual. And so that is a nice benefit for anyone who is looking to get to do this training course. And I'm going to use that segue to turn it over to Maziar to talk about the 5G 6G essential protocols and procedures training course.
Okay, thank you very much, Brad. Well, the 5G lab course, it is a training course when we examine and look at the details of the protocols used in 5G core. So basically, the course is having several learning components, and all of these components are contributing to the learning process of the protocols. So these are the main components that are building up the whole course. First of all, we look at the theoretical part. The theoretical part is based on 3GPP specifications. So we are looking at a standardized kind of protocol and how this network is built on based on that. Second component in the lab is a simple tool that we have created to generate customized traces. So that is what is called virtual lab. The third component is that we are, by producing customized traces, we will do trace analysis using Wireshark. So basically, we will go through every single message and look at every single information element that is used in that particular protocol. And the last component of the learning components is the practical part. So we have this hands-on element of doing exercises. Based on traces and based on the virtual lab, we have some 100 exercises to go through. And we also provide explanation in text, what to look for and how to do that exercise. So what I will do is that I will just present each one of these components in one slide and see how this course is built up. So let me begin by looking at the study part, the first component. So perhaps we can click to next slide. Yes. The course comes with a full book. We call it 5G lab book. It's around 150 pages of theory. Basically, the book is built up by slides, and the trainer will go through those slides. And for every slide, there is explanation in text. The goal of this theoretical book is to look at the protocol structures and how the protocols are operating, looking at the messages and information elements available in that particular protocol, what messages and what information elements are mandatory, what optional information elements are there, etc. Also, we look at the protocol procedures, what procedures are available in that particular protocol, if there are any procedures. And then to the right side, you can see that we can see that protocol in action. So we look at a scenario, and in that scenario, we'll see where that protocol is used. So that will basically give us a fundamental theoretical understanding about architecture and also protocols and in what interfaces they are used. Next is that we can go to the next slide. So we are using this simple tool that is our virtual lab.
To focus on talents and gain. Course combines expert 5G theory with practical, hands-on exercises. Using a cloud-based lab, you'll move from learning core concepts to safely applying them in real 5G scenarios. Now let's take a closer look at the two main sections of the lab, the Traces tab and the Topology tab, where you'll find the heart of our open source 5G system installation. Here we've created a minimal setup of network functions and NFs implemented as containers. Each NF represents a crucial component of the core network. What's exciting is that you have the power to reconfigure these NFs with customized settings, tailoring the network to your specific needs. On the topology panel, you'll see a visual representation of the 5G network. The NFs are interconnected to form the core network infrastructure. You can easily identify the various NFs, such as their MF access and mobility management function, UPF user plane function, SMF session management function, and more. This visual layout allows you to understand the structure and relationships between the NFs. Within the topology panel, you have the flexibility to interact with the NFs. You can access their configurations, modify parameters, and experiment with different setups. This hands-on experience empowers you to explore the inner workings of each NF, gaining a deeper understanding of the functionalities and the overall 5G network architecture. It's important to note that if you ever want to start fresh, you have the option to reset the network to its default settings at any time. This allows you to experiment freely without worrying about any irreversible changes. The lab environment provides you with a safe and controlled space to unleash your curiosity. Within the Topology tab of the 5G lab server, you'll find a powerful panel that allows you to simulate the most common procedures in 5G networking. This simulation capability enables you to experience and understand the fundamental processes that occur within a 5G network. The simulation panel provides a user-friendly interface where you can initiate procedures such as registration, PDU, session establishment, and more. Let's take a closer look at some of the procedures you can simulate within the panel. Registration, for example, allows you to observe the process of a user device connecting to the 5G network and establishing its identity. Through this simulation, you'll gain a comprehensive understanding of the registration flow and the exchange of signaling messages involved. When a procedure is simulated in the Topology tab, the resulting PCAP file is automatically added to the Traces tab. Here you have two valuable options for analyzing the traces: the sequence diagram view and the ability to download the PCAP file for analysis in Wireshark. The sequence diagram view provides a visual representation of the signaling flow in the captured trace. It allows you to understand the chronological sequence of events and the interactions between different network functions. This visual representation enhances your comprehension of the signaling process, making it easier to identify and analyze specific messages or procedures. Additionally, you have the option to download the PCAP file from the Traces tab and analyze it using the powerful capabilities of Wireshark. Wireshark provides a vast array of filters and analysis tools for dissecting and interpreting the captured trace. Explore various protocols, apply filters to focus on specific elements, and gain a detailed understanding of the underlying network behavior.
All right. So in our journey of going deep into the details of protocols, next step is analyzing the traces that we have just produced. So basically, for every topic, whether it is a protocol or a scenario, we have seen the theoretical part. We have seen what the protocol is supposed to do according to standards. The second was that we have created a customized trace. We have configured all these parameters that are needed for learning purposes of that protocol. Next is that there is a extensive trace analysis included in the course. So basically, we go through every single message in every single protocol. And we are looking at information elements that are mandatory to use. So this way, we have basically a clear trace that has no fancy features. There are no vendor-specific information, or there are no extra features. So basically, pure, clean, working trace. And remember that we do this only for training purposes. So once we have done this trace analysis, that is a result of this virtual lab, and have looked at end-to-end signaling scenarios, then we come to the next and last component, and that would be the exercises. So we can go to the next slide, where we have, as I mentioned before, there are more than 100 different exercises, and exercises are basically based on the very fundamental knowledge base that any engineering need to be able to work with, for example, troubleshooting or optimization, operation, etc. So exercises are, you can see to the left that there is a list of questions, and below the questions are explanation in text that is helping to find that particular answer to that particular exercise. Some of the exercises are for learning purposes. For example, find this parameter. What is this parameter used for? For example, follow-on request in this example. Why is it set to 1? So to answer such a question, students need to basically do a research, find what that particular parameter means, and then find it in the trace, in the correct protocol and correct message to be able to answer that question. Some of the other exercises are, for example, exercise number 5 in the example. What is the identity that is used when a UE powers on? So a lot of people can answer that just by reading the question. But we can also go to the trace, find the correct message that is carrying that initial registration. That would be the NAS protocol. And look at the registration request message, find that information element, and in that information element, realize that identity was that Suchi in this example. And then next question is to write down that Suchi value. So it's a comprehensive book that will go through not only theory, but also a customized trace that can be analyzed, and then exercises that are built around that the whole trace. And I think that was my last slide for this course. Yes.
All right. Thank you so much, Maziar. Can move
Thank you.
forward. All right. Now that we've heard from both Brad and Maziar, we wanted to highlight some of the key components of the training. So what makes the program stand out? Let's see. You'll get hands-on experience with a secure cloud-based 5G testbed. The training is flexible and self-paced, 11 hours of on-demand content. You'll earn an IEEE certificate with PDHs, professional development hours, a digital certificate, and digital badge from Ray Castle. And you'll join a global network of over 450,000 IEEE members and 300,000 Ray Castle trainees. It's a practical way to recognize a practical recognized way to level up your skills. Next slide, please. The program is ideal for a wide range of professionals: system engineers, integrators, network operators, engineers in operations, optimization, and troubleshooting, vendors, regulators, handset manufacturers, and more. If you work with or want to understand 5G signaling, this training is for you. Next slide. Thank you. And we just don't want you to take our word for it. Here are some additional testimonials as well, sharing it's a very comprehensive training. Keep up with everything new. These courses are very useful for me. It helps me in current activities and prepares me for what we are going to do in a short time. The feedback has all been positive, but now we'd like to hear from you. Please open up the Q&A portlet and submit your questions if you haven't already to all panelists, and we'll answer as many as we can. All right, we'll just give you a few seconds to do that. All righty. Okay, we have a few questions coming in. Feel free again to open up the Q&A portlet, as well as share anything in the chat, reactions to the session, or any other comments. So we'll start with the first question. Maziar, Brad, you let me know who you think would take these. Just won't be me, since I'm not as technical and well-versed in 5G as either one of you. But we'll start off with, can you define what 5G advanced really means for network intelligence and performance? Maziar, are you able to take that one? You're on mute if you're speaking.
Oh, sorry, I was on mute.
That's okay. Thank you.
Yeah. Really, in the first course, which is protocols and procedures, there are no AI involved. So I know that in release 18 and release 19 especially, there is something called SEAL, SEAL, that is a service enabling layer from 3GPP that enables verticals to get access to various services. However, in our course, we don't look at that part. We go as far as looking at API calls and API definitions, the service-based architecture, etc., but nothing especially for AI. So if you're looking for AI enabler layer, that is AI MLE, that is the 3GPP terminology, AI ML enablement. That is not covered in this course, but it is a release 19 stuff. And the latest specs is from 13th, I think, end of September this year. So I'm just about reading those specs. Nothing covered in this course. I don't know if it was enough answer. Sorry.
Yes, that's great. Thank you. And we also have one, it looks like for you, Brad, for the test bed. Hold on one sec. I have too many. Let's see. How do hands-on platforms like the IEEE 5G, 6G Innovation Testbed help bridge the theory practice gap?
Sure. So I think, the most obvious way is that the hands-on aspect of it, I think it just gives users a sense of control. So you learn something in theory and it's in your mind, but if you haven't actually touched something or done something that makes it feel real, it still feels like a theory. But when you go into a platform where you can change some settings and then see how it turns into a different outcome, and whether that might be how network slicing or maybe an API can change the way a streaming video is delivered to a user. And if there's network, let's say there's congestion in the network, and it causes a streaming video to get pixelated and slowed down. But if you then insert an API that tells the network, hey, if someone's streaming a video, you have to treat that user different than someone who's just talking on their phone. And then when that API is in place, you see that even in the face of congestion, the streaming video does not get pixelated. That's the kind of a scenario we've replicated in the test bed. And when you see something like that, you really start to understand the difference between theory and practice. And so I think those who get to do experiments in a lab setting like the Ray Castle Lab or the IEEE test bed, it will build their confidence when it comes to, hitting the job market or advancing in the job that they already have.
Thanks, Brad. There's another question regarding to share the link to the course program. We will do that by the end of the session. So new that. All righty. Let's see. And even when I'm not sure, Nazir or Brad, what are some emerging technologies that you think will rely most heavily on 6G? I know where that's about 5 years away, but we know it's under development. So is there anything that you can speak to regarding emerging tech relying on 6G at this time?
I can say a couple of words about that. I mean, I am looking only on the core network evolution. There are a lot of activities when it comes to verticals. So basically, we are forgetting that the end user of a mobile system is a handheld device. So forget about that. Mobile broadband, we have it. We have had it in more than 20 years. So now verticals are very important. So the whole IoT world, the whole kind of a robot that is controlled with 6G infrastructure. The whole use case, which is called ultra reliable, low latency communication. So there are a lot of activities around that. So as I said before, SEAL and AIMLE, those are two kind of concepts that are now getting bigger and bigger if we look at the 3GPP specifications. However, we don't know if it will be reality in future. We have to wait a couple of years, maybe 5 or 10 years to see how it is in action.
Yeah, I agree with that. And I might only add, if anyone's looking for very specific examples, something like telesurgery is an application that people talk about that might require a 6G as opposed to a 5G connection. So the ability for a doctor to perform a surgery when they're not actually in the room, which sounds very sci-fi and kind of horrifying, but they say that 6G will enable the tactile internet, which means that a doctor might actually be able to get a tactile feel of what's happening in another part of the world and therefore be able to perform a surgery. So it's fascinating and crazy to think about, but that is one of the things that gets discussed when it comes to 6G.
Absolutely. Thank you both. Just wanted to respond to a couple things in the chat. The on-demand recording of this webinar will be available at the completion, I guess, within 30 minutes or so. It usually goes out. Hans, that's for you. And anyone who is looking for the link to the program, it is now also in the chat, and it will be also embedded in the presentation before we end. All right. Thank you, Maziar. I see that added there.
Yes.
Awesome. So we'll take about one more question. Let me just see, because we have getting closer to the top of the hour. I didn't hear anything about ethics, so I wanted to just throw this one out at both Maziar and Brad. What are some ways we can ensure ethical and secure use of AI and machine learning in autonomous systems powered by 5G, 6G? I know that we talk about a lot of that in terms of AI, but I didn't hear too much, and if that's in the training at all in terms of the 5G, 6G protocols.
I can just add to that question that, I mean, 5G as an infrastructure, as a network, it has quite good security specifications. So I go through 5G security, which is kind of ciphering, integrity, the 5G authentication key agreement procedure. So all that is included in the course. However, for a particular service or feature, for example, AI or ML or NWDAF, etc., those are not covered in this course. This is giving a fundamental understanding of the protocols in 5G. But I refer to 33 series, which are having a lot of new specs when it comes to security, but also ethics, etc. Yeah.
Awesome. Thank you.
And I guess I'll add that I actually, as part of my work in Future Directions, work with a lot of IEEE volunteers who are focused on AI, and they talk about the ethics and the concern about ethics. And you know, one thing that a lot of them agree about is that companies that are designing autonomous systems, it's in their interest to make sure that everything is ethical and secure, because if it's not, then that's blowback on them, potential lawsuits, etc. But also, you know, thinking about ethics at the design portion is really crucially important. And I know that the IEEE Standards Association actually has a course, a certification about ethically aligned design. And it's called IEEE Certified. And that is a way for companies to get training on how to think about AI and ethics and responsibility while they're designing their AI systems or processes or protocols.
Awesome. Thank you so much. Edmund, I see you have a couple of questions in the chat. The lab environment is accessible at purchase of the training, as well as what Brad mentioned. The cloud-based 5G test bed is also included, 3 months access to that. Alrighty. And then, I'm sorry, we start closing the session at this time. Next slide, Amy, please. The telecom industry is evolving fast, whether you're designing systems, integrating networks, or troubleshooting performance issues. Staying ahead of protocol advancements is key. This program is your opportunity to sharpen your skills, reduce operational gaps, and position yourself as a leader in next-gen connectivity. If you'd like to explore the training further, you can scan the QR code. The link is also listed there as well. And if you have questions after today's session, feel free to reach out to us, especially if I haven't gotten to your questions, my apologies, at 5G60 protocols at IEEE.org. If you have questions specifically for Maziar, we can get that over to him and his team as well. Upon leaving the session, please complete our feedback survey that will appear when you exit the platform. And then lastly, I just want to thank all of you for joining, and for those IEEE members and IEEE staff that have joined. Again, happy IEEE Day, and I wish all of you a wonderful rest of the week. And again, we're here to answer any questions. Please let us know if you have any for either of the presenters or myself, and we'll get those answered to you. Thank you, Phil. Thank you all. Have a great day.